Welcome back to the South Carolina Manufacturing Conference and Expo right here on SCBIZtv. In case you missed our prior session, Collaboration Produces Innovation. It is now archived on SCBIZtv and you can watch it whenever you wish. Our next session is Industry 4.0 Trending Topics. We have a great lineup of guests in this session. Topics we'll cover include robotics and sensors for the human well-being, driving zero downtime with predictive maintenance, and industry partnership for machine vision with deep learning. We're going to take a quick 90-second break. Let's watch this informative video that was submitted by Venkat Krovi, who is the Michelin Endowed Chair of Vehicle Automation at Clemson University's International Center for Automotive Research, or CU-ICAR. Venkat will also be with us just a little bit later, providing another presentation. And when I return, I'll be joined once again by Catherine Hayes, who is the Industry Manager with SCRA. Don't go anywhere, we'll be right back.
We have out here the Smart Companion robot, which at face value shares about as much in common with this cart as your modern day smartphone shares with the old rotary phone. If you look at a modern day smartphone, the intelligence that has gone into it, the autonomy, we wanted to include some of that capability into the Smart Companion robot.
The automotive final assembly is a very manual process. So having a Smart Companion will support the associate by eliminating some of the walk time back and forth to fetch parts or tools by making these things available on command.
This robot can be applied to many manufacturing tasks. For example, in BMW plant, if they want to carry, transport or manipulate heavy parts, it's very expensive and not flexible. And for this, you can use a very small force to manipulate or transport the same amount of payloads.
The Smart Companion robot has two modes of operation. One is when it carries heavy loads, and the second mode is one where it's able to track different objects. It is able to anticipate and assist the worker on the shop floor and hands you the tools at the appropriate time. The core of all of this effort is to be able to take cutting-edge research such as this that we're developing here at Clemson and transitioning it so that it can actually find applications in real-life settings.
Welcome back, everyone. That was Venkat Krovi. Now, Venkat has a title long enough to where I need to read it to make sure I get it right. Venkat is the Michelin Endowed Chair of Vehicle Automation for Clemson University, International Center for Automotive Research, and of course, we all know that as CU-ICAR. And now I'm back with Catherine Hayes, and of course, Catherine is the Industry Manager at SCRA. We've been together a couple times today. Catherine, how are you?
I'm good, thank you, Rick. Thanks for having us.
Good to see you. Oh, please, I'm glad you're back again. We're going to talk about robotics and sensors now. Venkat is going to come back and join us and provide another presentation to us. But we're going to see three presentations, Catherine, here in the next half hour or so, all from companies, all of which have co-funded projects with SCRA. Can you tell us about that, a little 20,000-foot view?
Sure. We have something called a demonstration grant, where we work with an industry partner and co-fund the development of a project to de-risk the pilot project. All of these projects need to be scalable to multiple lines, products, machines, plants. And in the case of an academic partner like CU-ICAR, we work with the faculty researcher, case Venkat Krovi, and we help to fund a project where they also have industry partners. In this case, the project that Venkat is working on is an NSF grant, and SCRA has a membership with them through CU-ICAR, and the project is specific to micro-positioning. But Venkat will explain this is a wide applications.
Right, got it. All right, folks, let's hear Venkat explain that. This is Venkat Krovi. He's got a nice presentation. I've seen it. I think you'll enjoy it. We'll be right back.
Good afternoon. My name is Venkat Krovi, and I'm going to tell you a little bit about the Robots and Sensors for Human Wellbeing Center that we are setting up here at Clemson University. I'm a professor in Clemson University. I'm the Michelin Endowed Chair for Vehicle Automation. And I'm going to be talking on behalf of a group of colleagues, Dr. Matthias Schmidt, Dr. Jerome McClendon, Dr. Pierluigi Pisu, and Dr. Sophie Wang. And our group has participated in proposing for and being awarded an NSF IUCRC center. But first, let me tell you a little bit about myself. I'm the Michelin Endowed Chair Professor of Vehicle Automation here at CU-ICAR, right here at Greenville. I've worked in the area of robotics now for over 25 years, and in this time I've had the opportunity to work with a wide variety of application arenas. But for the purposes of today's discussion, we'll focus our attention on robotics in manufacturing, and in particular some of the emerging trends for robotics in manufacturing. The key components of this now are, of course, the hardware, the high-fidelity cloud computation, and the human in the loop. And we'll get a chance to talk about each one of these shortly. So first and foremost, I wanted to discuss what is a robot. I think there's a lot of interest in defining robots. For our purposes, we'll think of a robot as a tool that has the ability to extend human reach in some of the dull, dumb, dirty, dangerous environments. In particular, many aspects on the manufacturing shop floor fit this bill. And to this extent, you now have an articulated mechanical system that now helps you perform these dull, dumb, dirty, and dangerous tasks. It comes through a blend of sensors and actuators coordinated by a computer. But increasingly, we're finding that the intelligence comes not simply from the individual robot, but from an orchestrated group of robots along with other sensors. And so over the past 20 years, we've seen an enormous change in what happens within within a factory floor. The increase in connectivity, initially in the form of wired Ethernet, but now increasingly in the form of wireless Ethernet, is providing enormous new capabilities. But the key component to this still remains the people and processes. And unless we are able to match the robots to help create value, the adoption and the ability to realize this value remains limited. And so the last piece that I'd like to emphasize in this slide here is that we're seeing an immense number of application verticals emerge. And in a traditional sense, robotics might have evolved within one particular vertical, say the home or transport or buildings. But increasingly, the cross-pollination between these different verticals is what is supercharging the ecosystem. And so it's not too much of a surprise if I were to say that there are advances that the Roomba might have made in the context of home robotics that might be relevant to the factory shop floor. And we'll see how that is in a short while. So out here at CU-ICAR, we end up looking at this from this lens of cross-pollination. And some of the application domains we're looking at are, of course, the on-road. There's an immense interest in the off-road. But most critically for this discussion, we'll focus our attention on developments for the manufacturing shop floor. So the lens from which we view the manufacturing shop floor is that it forms a microcosm of a smart city. So you have the movement of people and goods from point A to point B. Oftentimes, this movement needs to be orchestrated carefully, and it's a synchronized dance. And to this extent, being able to now provision the right kinds of support required a level of sophistication that in previous years perhaps was not possible, but increasingly is starting to become possible. So you're starting to see aspects such as collaborative robotics, manufacturing assembly assist, cognitive and physical human assist, smart logistics, and the industrial IoT starting to make steady inroads into the manufacturing shop floor. But the challenges for any one of these now still remain the verification and validation and the development of the KPIs that hopefully help to build both the technical case but also the business case for adoption of these onto the manufacturing shop floor. And so the frame from which we approach this and how we look to help South Carolina manufacturers is to help them evaluate this technology as well as within the context of specific use cases, wherein, as you can see here, there are actually two different facets that now contribute to adoption. The first and foremost is whether you have the core innate intelligence that comes by the virtue of the sense, think, act, and doing this in real time. But increasingly, as I discussed earlier, it's not the ability of one individual agent, but it's the ability of that agent together with other intelligent agents, components in the real world, the virtual world, and most importantly, the human user, that ends up creating a process. And as this process now interacts with individual workers for an individual level autonomy task, or working together in small groups at a multi-agent cell level autonomy, or even working with a manufacturing execution system to create a factory floor-wide autonomy, there exists the opportunity, and evaluating the value stream that is created by this opportunity is what we would like to pursue. So in the context of I just wanted to give you a very quick overview of some of the past projects that we might have executed. I think Rick would have played this initial video up front where we typically work with smaller scale robotic systems, novel robotic systems that we are looking to now deploy within the shop floor. The core underlying premise is that people are now used to having intelligent assist. Most of you carry a smartphone. The smartphone today provides for you something much, much more than just the ability to talk to someone. You're able to set alarms. It acts like an intelligent assist for you. And to that extent, as we now bring in a next generation of people on the manufacturing shop floor, they are accustomed to in their day-to-day lives and expecting similar types of assists on the shop floor. And so while we may prototype some of these funded by NSF and other projects, there's a real challenge in translating this into something that might actually work on the shop floor. And so we look to take this through different rigorous steps of verification, validation at mid-scale commercial off-the-shelf system, with mid-scale commercial off-the-shelf systems. And to do this now also with full-scale systems. And so what you're seeing here is an example of a full-scale mobile manipulator that acts as we call it the smart companion robot, that acts like an apprentice on the shop floor. It goes, it prefetches heavy parts, and it positions them waiting for an associate to now come and perform the final finishing touches. So it's this sort of synchronized operations of man and machine that we believe are the wave of the future. And so this project that you just saw a little glimpse of was part of a Manufacturing USA Institute funded project, where we call it the Smart Companion Robot. The elevator tagline for it is, it's an R2D2 for the shop floor, in that it can anticipate and assist both cognitively and physically. And in order to be able to do this effectively, some of the components that it requires are a situational awareness. Where am I and what is around me? Manufacturing shop floor can be a busy place. And once you are actually able to map out the diverse set of obstacles, static and dynamic, being able to have the mobile robot traverse this autonomously and to be able to manipulate things with its arm, and to do all of this synchronized within a digital twin was what we were funded to do as part of this project. There are other projects that we've worked on in the past, and these now include things like the collaborative robotic vacuum cleaning project, where you're seeing as different vehicles come down the production line, each one's ever so slightly different, and the ability to now have a robot arm assist in getting most of the slag out of little bits of slag from within the chassis of the vehicle as it comes out of the body shop was something that was previously being done by two humans, one on either side, and the ability of the robot now to take over this dull, dumb, dirty, dangerous task is really what was creating the value. We had a chance to talk about the heavy payload assist robot, and so I'm going to skip over that. In this last little vignette that you're seeing here, this is an example of a collaborative robot-assisted hatch seal placement. You see that the actual placement of the seal on the lip of the hatch can actually be quite a complex task for a robot to achieve. But once this has been placed lightly on the lip, actually getting a robot to now roll over that hatch to make sure that there is a uniform pressure and seal. And to do this repeatably and reliably while saving the workers from ergonomic challenges such as early arthritis for hands is actually one of the ways in which we see robots and humans working together. And so last but not least, I wanted to talk a little bit about an ongoing project that SCRA has funded. This is what we are calling the Scaled Vehicle Formation Testbed. And we're looking at the combination, the merger of ultra-wideband and 5G based localization together with the SLAM technologies. So this is a project being led by my colleague, Dr. Matthias Schmid. And the core question that we are asking here is, we see two big streams of operation of two big streams by which intelligent systems are being deployed. On one hand, you see the self-reliant robot stream of thought, which is, how can I put increasing numbers of sensors on a robot to make it completely independent and autonomous so that it can recognize everything that's around it and make decisions for itself. And the other side of that, the flip side of that coin, is trying to come up with a robot system that now can communicate with the surrounding infrastructure, perhaps take advantage of the ability to connect wirelessly to a network, and to be provisioned information just in time from other neighboring intelligent systems and from the infrastructure. And so the right amount of trade-off between these two, so there are two facets to this. The first facet, as I've talked about, is the ability to realize this technologically, in particular in a specific use case setting. The use case we are now thinking about is a factory shop floor, and the domain often brings about interesting challenges that need to be overcome. Things that might work just fine in the outdoors may not work indoors. But the other and more critical thing is, in many other cases, you're looking for deployments that tend to be one-off. Whereas on the manufacturing shop floor, you're looking for 24/7, 365 type of reliability. Oftentimes, these consistency and reliability concerns create immense challenges for the same types of technologies as we've discovered. For example, things like SLAM, simultaneous localization and mapping methods, that might be useful to determine the location of a robot for short periods of time, 10, 15 minutes, then start to drift once you start to come up to 10, 15 hours worth of operation. And so the ability to evaluate a performance of these robots under such conditions, together with the development of business metrics that will allow people to evaluate the business case for deployment of these robots, is an area that we are now investigating as part of this project. So the core components of this now here really are, we have a robot arm mounted on a base that now has a variety of autonomy-related sensors and sensing algorithms. But we also have an ultra-wideband-based localization system that now allows it to create centimeter-level localization. And so together, we are looking to evaluate if centimeter-level localization, people have claimed that centimeter-level localization is the key technology for successful deployment. And so part of what we are looking to do is look to see the trade-offs that might occur, the computational cost, as well as the installed infrastructure cost, as well as the operational cost for doing things either using only the localization, external localization support, or by doing this with the simultaneous localization and mapping. And in this, what we are doing is building off some of our past expertise in doing simultaneous localization and mapping. Here, this slide is effort that we had done for both on-road and off-road settings, and being able to take this to then develop the additional higher level semantic maps and the real-time cognition, and seeing how this will assist both in the off-road setting, which is what this slide is about, but also how this will assist in a manufacturing shop floor setting. So the multiple purposes of this grant can help and assist in both the manufacturing shop floor based deployments, as well as some of the other deployments that we had talked about. So if people would like to find out more about any one of these, we welcome your emails. My email is noted out here. And I just wanted to say that in addition to some of the things that we've showcased today, We also have a whole host of expertise across the spectrum in almost all of the Industry 4.0 technologies shown here. So our center, the Robots and Sensors for Human Well-Being, is well positioned to help support all of these activities. Thank you.
Welcome back, everyone. Thank you for joining us here on SCBIZtv for the South Carolina Manufacturing Conference. That was Venkat Krovi, and he is with CU-ICAR, and we appreciate his participation. I am back again with Catherine Hayes. She is the Industry Manager for SCRA. And Catherine, we are now going to be talking about, going to hear a presentation called Driving Zero Downtime with Predictive Maintenance. We're going to hear from a couple of guys. One of them is Tyrone Ellis. He is with Trane Technologies, and the other is Mo Abuali with IoTco. What can you tell me about this?
Well, I think this is a fantastic project. It's a great example of Trane Technologies really integrating with various plants from the very beginning. They had a cross-functional team selected. They are thinking how they will scale. Trane has a very great opportunity in their plant because they've combined multiple plants. So they have legacy equipment and state-of-the-art equipment. Mm-hmm. And IoTco is working with them on predictive maintenance for 3 different types of equipment, which is, again, they plan to scale to multiple plants when successful.
How did these two companies, how did Trane and IoTco hook up?
Well, actually, they knew each other before SCRA got involved. Right. But SCRA was helpful to recruit IoTco to South Carolina to establish a presence here, and then to help co-fund this project, demonstration grant with Trane Technologies, and IoTco as the technology provider.
Tell me what Trane does.
Well, at that facility, they do commercial HVAC equipment. Mm-hmm. Of course, they have a wide range of products, but that's the primary product coming from there. I mean,
that's what I know them as, but I didn't know if there was something else there that I was missing. Okay, Catherine, so we're getting ready to watch this presentation. Again, it's called Driving Zero Downtime with Predictive Maintenance. Tell me what we're going to see.
So Mo Abuali with IoTco is going to present the fundamentals of the technology and how it works, and how really having an ROI from the very beginning is critical to success. Then Tyrone will show more about the actual application and why this is important for Trane Technologies.
Okay, let's take a look. Folks, this is a presentation from Tyrone Ellis, who is the Enterprise Director of Global Engineering Excellence with Trane Technologies, and Mo Abuali, the Managing Partner for IoTco. Take a watch, and we'll be right back.
So hey, good morning, good afternoon. This is Mo Abuali. I'm a managing partner at IoT company, and very pleased to give this short presentation here today with Tyrone Ellis, Enterprise Director, Engineering Excellence at Trane Technologies. Tyrone, thank you for being here.
Thank you, Mo.
Starting the presentation, we want to discuss today a zero downtime application for predictive maintenance with a case study at Trane Technologies. Very briefly, IoT company is a digital transformation advisory organization, and we provide solutions around industrial AI and predictive analytics to manufacturing, including organizations such as Toyota, Maxion Wheels, and Bocar. And very pleased to be going through this short case study here with Tyrone today around their use of predictive maintenance technology in their Columbia facility. Just to set the context, the field of Internet of Things and its application in factories under the umbrella of the industrial Internet of Things has really brought forth strategies and initiatives like the Fourth Industrial Revolution. And the Fourth Industrial Revolution is really all about getting operations connected, capturing real-time data from the factory floor, utilizing that data with advanced analytics like artificial intelligence and machine learning to support organizations to deliver a very strong business case in their manufacturing, improving uptime, reducing scrap, and a mentality of thinking big and starting small, and looking towards the future of how you can scale those business cases across an enterprise. So with this in mind, we always like to start with the business case. It's important to understand the success criteria for making industrial AI and predictive maintenance successful on a factory floor. One of the metrics we use is overall equipment effectiveness, improvement of uptime in the manufacturing floor, and reduction of scrap is key to the business. And if you look at a predictive maintenance type of application, like the one that we'll discuss with you today, improving and sustaining a high level of uptime in a plant is important. And by being able to understand machine behavior and being able to move away from a reactive time-based approach of maintenance to a predictive and preventive approach of doing maintenance is allowing companies to really reduce their unplanned downtime significantly. And not only that, but you can actually integrate those systems down the road with your maintenance system and with your spare part system, and allow you to start reducing your spare part inventory and actually fixing parts just in time prior to their actual failure. So we're talking reduction in spare parts in the factory floor. We're talking improving maintenance scheduling, because you have a lead time to fix a machine before it even fails. And we have organizations that were optimizing their maintenance schedule to the point where they did not need overhead maintenance anymore. They actually completely eliminated overhead or weekend maintenance activities, and they streamlined maintenance over their 5-day Monday through Fridays. There's, of course, other industrial AI applications down the road as well that also relate to quality improvements. But at the corner of the business case is the vision of driving manufacturing towards a zero downtime, zero defect operation. And at IoTco, we provide a solution for predictive analytics called Predictronics, PDX. The solution has a high level of interoperability to capture data from machines, from sensors, from PLCs, and to apply industrial artificial intelligence on that data and convert that data into meaningful information and insights around the health of the machine and predicting with a high accuracy the remaining life of this machine's performance and diagnosing the root cause of failures. And one of the reasons we were brought forth at Trane Technologies is the set of solution templates that we provide to the organizations. We come ready with very strong domain knowledge around manufacturing and a toolbox or a library of about 25 industrial AI solution templates. Those solution templates have an analytics workflow behind them, allowing manufacturers to deploy these solutions in a very short period of time, usually 8 to 12 weeks. And this quick deployment allows more time to use the data within the maintenance organization and to drive a return on investment and a business case for the manufacturer. And I think one of the case studies we'll focus on today is around the stamping machines case study, where we are doing hydraulic press predictive maintenance at Trane Technologies. And that is actually a great segue for me to introduce Tyrone Ellis. Tyrone, thank you for being here today to share our case study.
Yeah, my name is Tyrone Ellis, and with Trane Technologies. We're a global climate innovator, that a company that was started here earlier this year. However, we're a very old company. We were part of Ingersoll Rand for many years before spinning off to become a pure play climate sustainability organization. A lot of our strategic brands are well known across the globe, such as Trane and Thermo King. But there's others that you'll certainly may know as well that are part of our portfolio. And where we kind of focus is really about bringing efficient, sustainable solutions when it comes to buildings, homes, as well as transportation industry. Next slide, Mo. Thank you. So the commercial HVAC business for us, which is our largest business unit for the company, the Columbia facility of Trane is actually been a part of the Trane business since 2003. It's, as you can see, very large from the perspective of 85 acres and supports all of our other plants for a number of years out of this plant in Columbia as somewhat of a feeder plant. But we decided back in 2017, so just a few years ago, to expand the footprint of Columbia based on the success that we've had at the facility and the leadership there, to make it a very large facility that consolidated some other facilities across the country into Columbia. And the facility now is more than 1 million square feet. And so it's very large with over 1,000 people at the facility. What's interesting about about Columbia is that it actually has a mix of new equipment as well as old equipment because of the integration of the older facility coming together with the newer facilities that were transitioned into the plant as a part of the expansion. So you have equipment that that goes over a pretty substantial amount of time when you think about the age of the equipment and the functionality of the equipment as far as being able to connect it or just sensors and other devices that are very relevant when it comes to trying to deploy predictive maintenance into a facility that's very complex, like the Columbia facility. And so the facility is LEED certified, which is a really important part of our strategy when it comes to achieving carbon neutral operations by 2030. And the facility is very involved in the community, as you see with some of the initiatives it has on the right. So next slide, Mo. So the project itself, predictive maintenance, really we're focused on improving OEE, specifically around the uptime component of the asset as a part of the pilot at the plant. And so if you look at the press machines, which for us is kind of a core piece of equipment across our operations. So we have it in multiple plants. And actually, I think in total, probably even close to over 100 of these machines across our plants globally. We chose this piece of equipment very intentional with showing the value of predictive maintenance and the PDX solution that IoTco offers on the market. And so if you look at the critical components when it comes to bearings, pumps, and motors, again, understanding that kind of leads into what information we wanted to collect as part of our data model in order to drive the predictive maintenance strategy around this equipment. If you look over to the right, it shows a nice visual in regards to normal versus abnormal performance on the equipment that actually can help lead to finding problems before, I guess, getting that information that finds a potential problem before it becomes a real problem, driving downtime on the equipment or the asset that would drive the machine operator and the technicians, what we call the equipment improvement teams, to go and react and drive any maintenance and understand what needs to occur before it becomes a problem for for the facility, driving up costs and scrap and other key financial metrics. So that's the way the project is framed up. What's really nice about the work we're doing on this project is that we've created a plan for every machine. And so in essence, based on the age of the equipment and the capability of the equipment as far as sensors, working with IoTco, we were able to come up with what the equipment could do or anything else that we needed to externally add to the equipment to ensure that we hit the project requirements and be successful with the pilot. Next slide, Mo. So a key takeaways for this that we learned through partnering with IoTco: think big, start small, scale fast. Really, really important concept that really I think a lot of organizations sometimes miss when it comes to scaling their projects. And so we wanted to make sure that the project had a strong return on the investment. As you can see, less than 1 year, and with expectations of up to 15% improvement in the asset uptime. And just by getting a cross-functional team engaged with IT, operations, manufacturing engineering, it's really been beneficial because of the excitement that is generating for this project, especially thinking about how we're going to scale across the organization. Second point is IoTco was chosen as a partner to shorten the time to value. I think one thing that really excited the team, as Mo showed earlier, these templates out of the box in their library really help us to accelerate the project. And obviously in manufacturing, it's all about how we drive improvements faster, and that's what we do. And so having this out of box templates really was a big plus. Their experience, they've been a great advisor for us, again, creating that plan for every piece of equipment and making sure that we can meet the needs of the business. I think other key point was just the domain capabilities, having strong project managers, that equipment expertise, and then the data scientists to help us create those models. And then lastly, and certainly just as important as the others, how do we, the center of excellence, how do we make sure that we can sustain this over time by training our internal training resources so we can scale across our organization. Next key point, SCRA and SCMEP, very valuable with getting this project off the ground for us. The benefit they bring to South Carolina, I can't state enough how important that is and how we should be leveraging those organizations with their domain knowledge, certainly access to grant funding that could help get projects off the ground. Very important, I think, for us in the state to leverage those two organizations even more than we do today. And then lastly, our recommendation from Trane Technologies is that this is not anything of the future when we talk about connected or smart factories and connected equipment. It's here today. So all manufacturers need to embrace this. And if we look at our supply chain requirements, we're really expecting our supply chain to get on board and accelerate quickly. And so I embrace Industry 4.0 and do it now. Thanks, Mo.
Tyrone, thank you for your presentation. Thank you for the opportunity to collaborate with you and the Trane Technologies team towards a zero downtime vision for your manufacturing. Please contact us at any time. Please connect with us on LinkedIn. And thank you all for your attention today.
Thank you.
All right, everyone, welcome back. Again, here with Catherine Hayes, Industry Manager at SCRA. Catherine, you saw it. What did you think?
I think it's a fantastic example of collaboration and a partnership with industry, with the tech firm, with SCRA, and also with SCMEP. This is one of those projects that we are all working together to try to find a solution and have success in one plant that will be scaled to multiple plants.
How was SCMEP involved?
They are also helping on the co-funding piece of this and managing the project with SCRA and Trane Technologies and IoTco.
Excellent. All right, we got one more to watch. We have watched Robotics and Sensors. We've watched Driving Zero Downtime, and now we're going to watch an industry partnership for machine vision with deep learning, and we're going to hear from a couple guys. One of them is Gus Collins. Gus is the managing engineer at JTEKT, and Scott Tobey is the CEO at FSI Advanced Research. Tell me about these guys, Catherine.
Well, I had the privilege to meet both of them some time ago, and JTEKT is working to find solutions for machine vision of surface defects. FSI Advanced Research is an expert in that technology, and we're adding the component of deep learning so that over time the machine vision algorithm learns what's acceptable and what's not acceptable. And then it helps a human be able to identify, yes, okay, this is good, this is bad. This is another example of a project with SCRA where we're helping to co-fund with JTEKT as our industry partner. And one of the things that Gus has shared with us is that it's really valuable to them to have the opportunity to develop skills and technologies in-house that might take longer than if you were working with just a vendor. So that's one of the opportunities, I think, with a demonstration grant to help on the development and de-risking a trial.
JTEKT, very large company. U.S. headquarters right here. Earlier we spoke with Antonio Vaz, who works at JTEKT, and he was sitting right here where you were, and we had a great conversation. They do a whole lot of stuff, yes?
Absolutely. They are a global tier 2 automotive supplier. That's their
right.
primary business.
Yeah,
And
please, I'm sorry.
that's right. And they are working on lots of new projects.
Yeah.
Not to be discussed openly at the moment,
Yeah,
but
understood.
they have really good opportunities for the future.
You know, Antonio also told me that. I believe 1 out of every 4, their products are in 1 out of every 4 cars that are driving down the road in this country. So they are quite the significant manufacturer here. Let's listen to their presentation. Again, an industry partnership for machine vision with deep learning. Gus Collins, managing partner at JTEKT, and Scott Tobey, CEO at FSI Advanced Research. We'll be right back.
Thank you, Catherine. Today we'd like to discuss deep learning machine vision, its industrial application and future promise, as well as our collaborative relationship between FSI Advanced Research and JTEKT, which was made possible by SCRA. Deep learning is at the forefront of machine vision technology. Although not entirely new, it has become feasible due to a fusion of high-power computing and advances in mathematical models for training. FSI has spent many years working with deep learning and applying it to industry problems previously not solvable by traditional rule-based machine vision. Through the catalyst of matched funding from the SCRA, FSI and JTEKT were able to launch a joint research initiative to advance the application of this new technology and solve some complex inspection tasks. Gus, can you tell us about JTEKT's motivation and JTEKT's value proposition?
Hi, Scott. Yeah, sure. So JTEKT's motivation is to investigate technologies that may someday allow us to replace some of the activities that have to be done by humans today. So inspection is one of them. Humans are very good at detecting certain flaws and quickly identifying problems with or with any kind of product. So today, current vision technology allows us to do some of that, but it's really a small percentage of the inspection work that goes on in a typical manufacturing plant. And the reason is that vision systems tend to be expensive, complicated. They're dedicated to a specific product or feature. They're not simple to train only with good pieces. You have to essentially tell it what every condition, NG condition may be. So today I see the development of open source software that's very, very powerful, coupled with the drastic reduction in cost and the drastic increase in capability of embedded systems converging to give us an opportunity to maybe change the situation. So the development of those systems, which we're going to talk about and you're going to tell us more in detail, is significant. So that's where the SCRA Alliance allows us to join in a development project, right? Because our options were either working with a turnkey supplier where you have a solution in the end, or carrying it out on our own, which requires significant resources and time. So the ability to leverage knowledge and resources on the outside really was appealing to us. So for us, I see this as a journey. It's not the end destination. It's a learning journey, and we'll be able to investigate all of these many challenges that would require us to overcome to get to a real solution. And I guess I'll let you tell us about deep learning.
Thanks, Gus. Deep learning involves the development of complex layered algorithms called artificial neural networks. These networks allow a machine to continually learn from very large data sets. For an algorithm to be considered deep, it usually requires at least 6 layers and sometimes more. Each layer is responsible for finding a specific pattern in the data set. Training methods can be supervised, unsupervised, or semi-supervised, with each method having a specific advantage depending on the application. Gus, can you tell us the advantages of deep learning and where it can be best applied?
So in my view, the biggest promise of any machine learning technology is trend detection and prediction. And this is would be done via the processing of large amounts of data and continuous retraining. So for in manufacturing, there will be a place for it in process optimization, product assurance, predictive maintenance, and many others. So in this effort that we're doing now, we're looking for product assurance, where we want to investigate a system that can detect a product that are not conforming. So and the biggest advantage, more specifically with this activity, is that we would like the system to learn and be validated only with good pieces, because programming and giving the rules that identify every defect condition is cumbersome, is difficult, and defects can be a very large number of causes for it, right? So I think that would be a major benefit. And then secondly, I mentioned before, but is improving the feasibility and financial justification of implementation if we can take advantage of open source software and very low cost embedded systems. So now obviously there's a lot of difficulties and challenges. I'll let you talk about that, Scott.
Thanks, Gus. To create an effective deep learning model, you must start with a good data set. And the data set should ideally consist of a large number of images that represent variations of good parts and defect parts. The data set needs to be labeled, indicating specific defects on the images. And this can be a very time-consuming process, but it's a very important part of the process. As we found out in our research, another important part of the process is to create a method to evaluate the results. This required us developing a system of result metrics that could be compared to various training models, as well as predict the real-world results. Gus, can you tell us a little bit about what you think the future looks like for deep learning in industry?
Well, so expanding on what I mentioned earlier, I think our hope is that this technology is not limited to visual inspection or inspection in general, and that it will give us, it's another tool that allow us to make machines and processes smarter, in the sense that it can provide significant information in the decision making and for optimization and detection and prediction of problems.
Gus, what do you find unique about the partnership between FSI, JTEKT, and SCRA?
Well, I think what's unique is, and I think we touched on this a little bit, but it's that it's very untraditional relationship between a customer and a supplier, right? And as a matter of fact, I don't think we have that. Those are not the roles that we have in this project. And of course, there's SCRA kind of incentivizing and providing that initial kick to get us together in the first place. But I think what's unique is that we were able to customize the scope of the project to meet our so that we could place it as part of our roadmap for development of technology internally, but also to make it so that it's attractive for a company like yours to help us in that journey, and with a longer term thinking that it's not just a small project, right? That it will continue, and so from our standpoint, it allowed us to utilize the knowledge and resources that you have to augment what we have, and still make it so that the problem statement is very specific to our needs. And I think that's very valuable, and I see that as being really the way of the future. You know, in the past, and even if you think about what we're using open source software and hardware that even the hardware companies now are providing more and more tools. In the past, it was all hide everything you're doing, right? And it's which means that's great, but you have to staff it, right? So you have to have a data scientist, you have to have a hardware guy, you have to have a software expert, and now with this open source ecosystem, it's a little different. I mean, we don't, you know, the idea is to reuse and not have to reinvent the wheel. So I feel very positive about that.
Thank you, Catherine, and the SCRA for making this possible.
Welcome back, folks. You just saw a presentation from our friends at JTEKT and FSI Advanced Research. Once again, I am here with Catherine Hayes. She's the industry manager at SCRA, and we are talking Industry 4.0 technologies. That's the third presentation you've watched. They've all been good. Hope you've enjoyed them. But Catherine, before we go, I thought maybe we could just touch on a few other types of technologies that maybe these presentations didn't cover. Let's start with additive manufacturing, 3D printing.
Well, Rick, once 3D printing was just for prototypes, and now increasingly it's for production components, especially in aerospace.
Mm-hmm.
Eventually, I think that'll also hit automotive and other industrial products.
Tell me, Catherine, about Extremity 3D. I've heard a lot about these guys. Who are they?
Yeah, so Extremity 3D is actually an SCRA, SC launch company.
It figures.
And they had a successful pivot into industrial applications for 3D printing. Mm-hmm. They use a variety of high-tech advanced materials, and they've had success working with tool manufacturers, meaning, you know, for hand tools, to protect both the operator using the tool and also the product where you're doing various automation.
Right, right. Let's move to another technology. How about smartware?
So smartware is a great opportunity in a factory setting, but also in a warehouse, in a variety of applications where you're using wearables, I'm wearing one now, right, to keep track of, it could be a variety of information, whether it's your steps, whether it's your reaches, whether it's the time to do something. I can tell you that Bosch used it recently to track where they had social distancing. Mm-hmm. So they were able to monitor people in the factory floor and provide real-time feedback that they needed to do something differently in a certain area to be sure that the operators could be distanced.
Right. You know, I've seen all kinds of cool stuff, right? You've got smart goggles, you got smart hard hats or smart boots that can tell you when someone is fatigued. It's like never ending, right?
Yes, and so we have another company with SCRA Module that's been very successful in reducing strain and risk to workers and operators in various facilities. And I think you bring up the kind of smart goggles. There's another technology which everybody has heard of, augmented reality, mixed reality, and virtual reality.
There you go, the fun stuff.
Yeah, absolutely. And that is used often for training. It's a great opportunity with one of our other companies, CU-ICAR. But in addition to training, that information can now be fed into the digital twin. So you have real-time actionable data that can help simulate what's going on the floor, not just what you hope is going on the floor.
Let's talk about one more thing.
Okay.
Human augmentation exoskeletons. What do you got? What is that?
So with an aging workforce and with some repetitive motions, it's really helpful to an operator to have augmentation. An exoskeleton is something that they can wear that at the moment they're passive devices, mm-hmm, that helps them in lifting and moving and twisting while they're carrying something heavy. I know that last year Toyota actually made 130 processes mandatory to wear exoskeletons. But to be fair, this is still an early technology and requires study and a lot of data to be sure that we're helping a person that's using the exoskeleton.
Right. my goodness. The technology just keeps coming fast and furious. Catherine Hayes, Industry Manager, SCRA, thank you so much for joining me.
Absolutely, it's a pleasure.
I appreciate it.
Thank you.
That completes the 7th session of the South Carolina Manufacturing Conference and Expo right here on SCBIZtv. In our 8th and final session, the economic outlook for the auto industry will be presented. It starts in just a few minutes. To move to the next session, simply click on the link below to enter the next scheduled part of our agenda. If you join us a little later in the show, just click on the individual session you wish to view. All sessions will be archived here on SCBIZtv, so you can come back and watch at your leisure. Don't go anywhere. We'll be right back. Thanks.